Good morning, everybody. Good day. It is 9 a.m. I am Patricia Dugan, head of community for Traefik, and we are coming to you live today. I'm in San Francisco, and I'm super excited to be with you today for the meetup that we have with Phil of William and Mary. So first, let me start by telling you, Traefik, is a great open source project, and we're an edge router, and you know what we are because we're here. And Traefik Online Meetups showcase ways that we're using traffic and or mesh to solve interesting technical challenges. Let's see, what do I want to tell you? So there's a couple of things before we get going. We have, today we're talking with William and Mary. It's Phil Fenstermacher, who is a very cool man. I'm super excited to hang out with him and introduce you to him. And he is going to present managing traffic everywhere, bare metal to containers to the public cloud. How exciting. They have a cool story over there at William and Mary. And William and Mary, I will wait so he can tell you all about it, but I have a thing for universities, and this is a very cool one. So as far as containers and traffic goes, I want you to know we have some events coming up, and I will put that in the chat box. The recording of this will go live. You can find it on our resource page as well. You can go to our YouTube channel and subscribe to that, and I will put that link in the chat box as well. Now, it's an exciting show today. You're probably going to have some questions for Phil. So what we're going to do is you can load them up in the chat box, and then towards the end, we'll go ahead and ask them, and he will respond. And then those will be addressed also post-event in a gist if you ask enough. So, and that's all I got. You can find us at Traefik on Twitter. I'm Patricia_Dugan on Twitter. You can find us in the community forum. And again, thank you for coming to a Traefik Online Meetup. We love them, we love you, and we're happy you're here. So now I'm going to pass this over to Phil, who's going to tell us a wonderful story about how they're managing traffic with Traefik over at William and Mary University. Take it away, Phil. Have fun, and thank you.
Thanks, Patricia. I'm going to double check with Patricia here that screen sharing is working. Okay, there we go. I had accidentally paused it on my end. Okay, I'm doing all this off of one monitor on a laptop, so hopefully everything goes well. So yeah, like Patricia said, talk a little bit about how we manage traffic all over the place, how we use the product Traefik. When I first looked at this title slide, I'm sitting here thinking, I hope people don't think that's a typo, but this is kind of exactly what we meant, because the product is only one part of how we're managing all of our traffic all over the place. So first, a little bit about William & Mary. We're a very old university. We were founded in 1693 by our royal charter. We're now public. We were private for, I don't know, a couple hundred years or something. We're a public liberal arts university. We're located in Williamsburg, Virginia. And we have a little over 8,000 students. I think we have 40 plus some degree programs, though a lot of our students do like the design year and major and all that kind of stuff. So we're all over the place as far as what we do. Which leads us to being all over the place from an IT perspective, what we support. We run everything from bare metal, we have VMs, we have a lot of containers on premise, we have a lot of stuff in the public cloud. Across all of our services, we don't do any one application at any incredible scale. So our request rates and everything else are fairly low, but we run a very wide range of services. We host everything from generic web apps, things that are enterprise applications, everything from ERP systems all the way through to WordPress and plain HTML pages for our faculty to showcase their research. We also run traditional DNS, authoritative servers, as well as resolvers. Since we're a university, we have a large dorm population, so we also are an ISP for a lot of our students, and we host things to back that. So similar, we have the things that go with traditional enterprise IT, LDAP, single sign-on, and within our infrastructure teams at William & Mary, we also have to take care of the monitoring system, the storage systems, and all of the stuff that you find at a traditional IT shop. And you never really know what a student group or a faculty research group is going to show up with needing us to host. So we're very much all over the place with what we end up having to run. So to that end, we kind of have a interesting, I should say interesting, it's probably kind of boring on-prem setup. and this is only a small piece of it, kind of relevant to this talk, I hope. So I'm just going to show all the different systems we have. We run Traefik, sits kind of between our container, our swarm, Kubernetes, whatever it might be, sits between our F5 load balancer and the systems themselves. F5 just kind of takes care of our, it's got some firewall stuff, some security things that existed well before Traefik and all these things existed. So our security teams and a whole bunch of folks like to have that insight that they can pull from there. So our on-prem stuff, we've got, a little bit of everything. Inside of our Docker Swarm setup, we're only running 5 bare metal nodes, but we've got about 80 services from Traefik's perspective that run in there. We're mid-migration between Traefik version 1 and version 2. That's kind of been an interesting and fun project, and I'm hoping that when we get to the demo here a little bit, when we kind of show how we actually manage the flow of our traffic, we'll kind of migrate a little dummy test app that I've written from version 1 to version 2. Inside of our Docker Swarm system today, it includes our university's ERP system. It takes care of everything from student registration, grades, anything like you'd expect when education is the business of the university, what we would host there. And we've got nearly all of that running in Docker. I think everything except for the database itself is running in containers at this point. Inside of our Kubernetes cluster, it's fairly new. It is separate from our Docker Swarm cluster. We're only at 5 virtual nodes, 10 routers, but we've only had it up for about 3 or 4 weeks now. And this is kind of our long-term plan, is to shift everything onto Kubernetes. The biggest reason is that inside of Amazon and all of our cloud stuff so far, we've been running Kubernetes there instead of Docker Swarm for the same reasons I think a lot of places have been. So we've just run an EKS cluster. We use auto scaling groups. Similar to the F5 on-prem, we run it by an elastic load balancer. And that's really just to get the fun things like the proxy protocol and the kind of the DNS failover fun. That way we don't have to do round robin DNS or anything like that explicitly. Inside of this one, we're running about 75 routers. We've finished our Traefik 2 migration about 2 weeks ago. That's also monitored by Prometheus. And we'll talk about how we aggregate all those metrics to one place to make it easy for our application administrators and everybody to deal with too. So kind of the management kind of layout of how we end up doing things is we have our SRE team. The name is constantly in flux. So that if you look on our org chart, you're not going to see SRE team, but I'm just going to use the term here a little more descriptive, I think. And that's the team that I'm a part of. We run Traefik itself and the clusters, and a lot of our internal apps that support ourselves, things like Prometheus and Grafana to help us read Prometheus and do useful things with it, all come out of all run in the same clusters. So we kind of eat our own dog food in that sense, to use the colloquialism. Our application administrators create the routers and services. They take care of the deployments, the upgrades. A lot of our container builds happen through CI/CD, but as a member of the SRE team, we end up doing a lot to help our SRE or our application administrators get everything up and started and help them adopt the container platform. And that's part of the reason we build our own stuff on it. The middleware kind of administration, which has been a really nice addition in Traefik version 2, is more of a shared responsibility. To support that, we, just a quick example, we have a lot of services that we limit to on-campus access. So to limit those, we can create a centrally managed middleware that's just a campus IP whitelist. We can throw our IP ranges in there, and then anybody else can adopt it. And then when our networking folks call us up and say, hey, we've made some changes to the network, we don't have to go track down every single service. We can just update it in one place. So it's nice in the sense that we can centrally manage everything, but at the same time, we can leave the components that our application administrators really care about up to them. So one of the challenges that we were trying to solve when we started looking at containers was our traffic management piece. In a traditional setup, you'd have an HTTP router, you'd have configuration feeding that router for different applications. In this case, I'm going to use app A and B. and then we have 2 instances of each. And let's say we decided we need to scale application B. Well, to scale the application, first we end up having to modify the configuration for application B, whether it's saying create more replicas or going in as far as racking and stacking new hardware and everything in between. Maybe even updating the configuration files themselves so they know about their new instance. So that creates our new instance for us. But then we also end up having to modify the router configuration or load balancer configuration to then route traffic to it. So now we don't have a single source of truth anymore, and that causes a lot of problems. Things get out of sync and are forgotten really easily, especially when people start thinking, oh, it's all right here, I can just make a change, and then things start to fall over. So this is probably a good time to mention that we manage everything with Git. All of our configurations are going into Git now, including our Traefik configurations, Traefik the product, as well as the traffic management itself. We use linting and basic compliance tests. We're using the Open Policy Agents conf test tool to test everything in our CI/CD pipelines. Assuming everything passes, then we auto deploy everything. From a security model, we kind of rely on a mix of the conf test with OPA and merge requests. We do limit a little bit who has access to do merges and pushes to our control repositories. That way you don't have people claiming the wrong domain name. Somebody working on a non-production instance doesn't accidentally use a production domain name and end up, half the traffic is going to a non-production instance and causing chaos all over the place. So one of the benefits we ended up with out of this, and this works with Traefik the product, but it also works, this is similar to how things have worked if you've been in cloud for a long time. We have not been, so for us, this was using Traefik versus like an auto scaling group has been very similar. Now, let's say we want to add a new instance. So on here, the slides, I'm really just incrementing the replicas. And this works in Kubernetes on the left and Docker, Swarm, Compose, whatever it might be on the right, just the same. So when we update this, we're updating one configuration now, and that HTTP router configuration is kept with it together in one place. So then when we add a new one, we just add a new instance of our application and everything gets taken care of at effectively the same time. We have typical things like health checks, liveness probes, whatever they might be, kind of solve some of the potential issues that get created there. This is important to us and really helpful from the perspective that things don't get forgotten. When people miss something somewhere, it's really easy for people to make mistakes. Like I mentioned earlier, and maybe we're adjusting a domain name or we're adding a new domain name. Maybe somebody, marketing folks, accidentally put www dot in front of something that didn't resolve before. Now we can add that, but then it kind of reminds you, oh wait, maybe I need to think about SSL certs, and everything ends up kind of in the same place. So we're not having one group of folks that can log in to the administrative console on a load balancer and a different set of groups taking care of the application. And it's so easy to forget about each other because they don't have to look at each other's stuff all the time. So kind of one of the biggest wins for us was just having everything in one place in that Git version controlled kind of way. And the rest of it is kind of the tooling and the special sauce that's enabled us to be able to do all of that. So one of the things we talked about, I touched on, but is really important, obviously, to routing traffic is DNS. We also manage our DNS stuff through Git. Like I mentioned earlier, we run authoritative DNS ourselves on prem. We're not using anybody like Dyn or Route 53 for our main www authoritative domain name. It also has automatic deployment. We have pretty extensive tests that have to run. It takes about 5 minutes to get through our CI/CD just for some configuration files. We test everything from validity. We do some sanity checks to make sure people didn't change the wrong, really important domain name and everything else. So we have to make sure all that happens. So what I'd like to demo is a move from Traefik version 1 to version 2. And now is probably a good time to talk about how we've gone about doing that. What we've done, and I don't have a fancy slide for this, but we moved everything by creating a new virtual IP address on our load balancer, and on-prem and in our cloud components, we created a new load balancer entirely. a new ELB instance. When we then we reconfigured all of our services to run either on both, or we had to update DNS at the same time. That way we didn't have to move our entire deployment and everything that went through Traefik at the same time. That way, a lot of our applications have different outage windows. Like I talked about, we have a very wide range of applications that we run. So in the sense that we've been able to move everything over to Traefik 2, it's being able to manage DNS has been a really key component of that. So what I've done so far, I'm going to jump over here to, here we go. So this is our little demo service that I'm going to run. Let me run back to our metrics that we have so far. So this is just a really dumb web server that I threw together that all it does is responds kind of it randomly within some guardrails, generates different response codes for us. So this has been running for a little bit. I've got a little loop that generates just under 1 request per second, just so we have some data to look at here. So what we're going to try and do is move this over to Traefik version 2. So I've already deployed another instance of it in Traefik 2. We can see there's no traffic going to it at all right now. And so here's our version 1 instance of it. You can see it's got the old labels that everybody was probably familiar with. And so we've also deployed another one over here that uses all of the Traefik version 2 labels that we would expect. And we've got a new network that we've created inside of our Docker Swarm cluster, just called V2. So we're always going to do the fun attempt a live demo here. So this is a typical DNS zone file. We follow the dates. I'm going to peek and see exactly what today's date is. So we're going to update the serial number in here, and then we're just going to jump down here where I have our new one and our new cluster. We very creatively named cluster 01. So we're going to take this and we're going to say migrate demo app to Traefik v2. So I've pushed that, and like I mentioned earlier, it takes, because of our tests take a little bit, and we want to see something happening sooner than the 5 minutes. I've got a little, we're going to kind of do this like a cooking show, and I'm going to try one of these things, and we're going to manually reset this and hopefully wait for some traffic to start showing up here and start dropping off on the old one. So make sure this is actually running correctly. Awesome. Okay. So now is probably a good point to go back and talk a little bit about why I titled the talk Moving from Bare Metal to Containers, VMs, everything in between. And a lot of it is that we're moving to this Git managed approach for all of our different deployments, regardless of whether or not they run in on VMs, on bare metal, or in containers. We're using the same approach to manage our traffic all over the place. What we're really accomplishing, and where Traefik, the tool, has been helping us, is that it lets us couple all that configuration in one place. Even if the configuration isn't related, we're still putting it all into, even when for VMs and bare metal, where we can't say, hey, create this piece of metal in this machinery that we've put in a rack, we're still able to define its configuration and what runs on it in version control. So we're putting as much as we can there, and through other tools like Terraform, et cetera, we're able to kind of mash some of that configuration even into traditional load balancer like an F5 or an A10, or I don't even know who else is on the market. There's a whole bunch of them at this point now. So any of them, we're able to kind of manage it that way. To help manage it, a lot of it is we have to monitor everything. Like I alluded to earlier, Prometheus is scraping everything. And we're using Thanos to aggregate all of our metrics into kind of a single central point. Like I talked about earlier, we had this thing, and we're actually starting to see some traffic show up on this one now. And if we go over here, yeah, we can start to see the traffic dying off. So that DNS change that we pushed, coupled with a little bit of hand waving magic, we can see the migrations happening. But if we jump over to another service that we have running on here, what's a good one to look at? This is our front end for our main. This is where our students go to check their grades and everything else. So we can see that traffic is still going, still in Traefik version 1. I will say our numbers are pretty low right now. We're in our graduation was a couple of weeks ago, so we're in our kind of quiet period at the start of the summer. Like I said, over here we have this starting to ramp up as data starts to show up. And this is all of our Traefik version 2 metrics. And so we've got a whole bunch of things here. None of these are especially high traffic or super interesting to look at, but it's all there. We've also, now's probably a good time to touch on the Traefik version 2 migration. We were able to approximate a lot of things that we had on our old traditional on-prem load balancer, things like fallback pages, fallback pools, so that if a service is down, rather than getting the generic 404 in the corner, we're able to swap that out for something that looks a little nicer. So that's kind of the demo of putting it all together and how we have everything pieced. Kind of the short version of how we manage our traffic everywhere is really Git and DNS. DNS, I don't know how a lot of other places end up handling it. For us, managing DNS with through Git has been kind of nice. We have that full revision control. It's really nice. I go on vacation or something, you come back and you say, show me all of the changes of how our traffic routing has changed, at least from a public facing perspective. And we also use it as our service of record. Which cluster is this thing pointed to, everything else? It's kind of our go-to piece. And then other departments are able to send us merge requests. Our computer science department runs their own servers. They're able to get in there and play and send us merge requests, and we can approve them from our phone, which is pretty nice. And like I kind of alluded to as well, we're getting to that point. I'm going to jump back to our traditional setup. We're getting to that point where we're able to start managing more of the components that run in our traditional system using a similar model. And Traefik, the product, has just kind of become our first thing that's fully able to work in that sense. So I'm hoping this can kind of turn into a discussion. I'm curious to hear what other folks are using. Thoughts, maybe you see something in here is like, wow, this is going to fall over on you. You should fix this, or what everybody else is doing. If you think of something after the questions are done, feel free to contact me. You can email me, pcfins@wm.edu. I'm also pcfins on Twitter, GitHub, GitLab, pretty much everywhere on the internet. So feel free to reach out if you have any questions that you don't think of now. So with that, that's kind of my prepared part of the presentation. So I'm curious what kind of questions, if anything, has come in quite yet.
Well, so everyone in the audience, if you'd be so kind as to please tell us maybe a little bit about what you're looking at in front of you as using Traefik and how that looks in context to what Phil has shown us. And then any questions that Phil can answer. Phil, I would love to hear maybe what it used to look like before you had Kubernetes or any cloud deployment, and literally what was the tangent point of when you started to shift?
Yeah, absolutely. So for us, the big shift to containers and Kubernetes and Swarm was when our new ERP system that we're running today kind of kicked in. It used to be a very monolithic application. The new one, I'm not going to go as far as saying it was microservice based, but it had a lot of different web front ends. And the vendor recommendation was a whole bunch of different domain names or different ports or something like that. And a whole lot of VMs that we were going to have to manage. And we were really looking for something that was going to smooth that over. So what we ended up going with was we went to a presentation. We were at a Usenix Lisa conference, and Swarm had only been out for about 2 or 3 months. And so we saw a presentation on how some other folks were using it, and it kind of struck us as this is perfect. But we needed session persistence. A lot of these applications are still very traditional. So when we switched to using this new one and we needed that session persistence, Traefik at the time was the only kind of ingress controller that was able to deliver that. So that's how we started down that path. And a lot of it has been trying to approximate what we were doing before. Things like I mentioned, session persistence, centralized whitelisting of IP addresses, things that would be very easily handled on a traditional load balancer, and things that we still do today. As a university, we still have everything from Solaris Spark servers in our data center, all the way through to like containers and all this, everything that I'm about to say new in our environment. It still feels new, but I think at this point, industry has adopted it pretty widely. But for us, it's just everything that, we're trying to approximate that. And at this point, we've been able to do that fairly successfully. Does that kind of answer your question?
Yeah, and you said something about not having to do round robin and things like that. What other efficiencies have you noticed? And by the way, I see we have a question. Yippee yippee. Yeah, I was just wondering what other efficiencies you see, and then we'll ask Michael's question.
Yeah. So can you repeat sorry, I was reading Michael's question. I saw it popped up right as you started.
Let's go to Michael's question. And if you don't mind, I'll read it out loud. How are you handling SSL certificates? Using Let's Encrypt and generating a new cert for each server instance doesn't scale. Are you generating them when you provision with Terraform and then copying them to a volume the Traefik container can see? What a great question.
Yeah, absolutely. So one of the things that we've been kind of fortunate enough to have at a university is we're pretty strict about, we want everything under that wm.edu domain name. From a branding perspective and from a ease of management perspective, the university community has done a nice job of partnering with each other. So the university community in the United States has essentially gotten together through a research network, and we purchase kind of an all-you-can-eat certificate model provider. So what we've ended up doing is we have a number of wildcard certificates as well as a few non-wildcards, and we provision them manually because most of our production applications end up at some star.wm.edu. We've been able to do that. So that's how we've gotten around using Let's Encrypt, because I agree it doesn't scale super quickly for a lot of stuff, especially with rate limitations. It's wonderful for personal use and for experimentation, but it doesn't start to work at those higher scale levels. So yeah, we use a lot of wildcard certificates, and we're working on trying to get things like, issue time and validity time and everything else down to make that pretty quick and easy. It's kind of nice. The same folk, like I mentioned earlier, the same group that manages our Traefik instances and the clusters themselves, we're also the folks that manage the DNS servers. So when a new DNS name request comes in, we can kind of catch it before we hit that merge button, and we just kind of have to know, like, oh, that's not going to be covered by an existing certificate. And we're a relatively small team. There's only about 3 of us. So it's not too hard to keep that knowledge around with everybody.
Let us know if that did not answer your question, or if you have more to ask about it. What about your stack, Phil? Like, did you, what else is on your stack that you didn't cover today, or did you cover it all?
Oh gosh, there's a whole lot of different things that are in here. I'm trying to figure what direction would be kind of the best way to go with it. I'm trying to think of what something maybe interesting that we have.
Yeah, I mean, I'm just thinking about maybe the people who are here, what their personal scenario looks like.
Yeah. So I think we were a little bit interesting, maybe, at least it feels interesting, that we were containerizing a lot of traditional applications, things that weren't designed for containers, instead of the microservices that, at least when I go to conferences and I hear other webinars, that everybody's launching the new stuff on containers. Because our IT department is relatively small, we have a lot, and just the number of services that we support, it's a constant battle for us to keep our servers in an up-to-date, not only from a patch perspective, but staying on the most current release. So the idea of moving to containers for us, it doesn't remove the need to keep on the supported versions of Ruby, Python, Java, whatever it might be. but it at least removes the server component from having to do that. And I think that by kind of clearing out that server component of it has allowed us to focus more on the application itself, especially around things like Java and Python versions that, especially for internal facing apps or little scripts. Now a small singleton script that does some very boring, mundane thing doesn't have to be rewritten simply because a version of RHEL or Ubuntu or whatever it might be is gone out of support. So I think I'll have to think on what's maybe interesting. Maybe after we get through Michael's next question, maybe.
Yeah, go for it. We have a question from Michael that's, are you making the move from TOML to YAML as you move from 1x to 2x? And I would love to extrapolate on that and on your migration to 2x, what this is looking like for you now.
Yeah, absolutely. We are moving from TOML to YAML. Since we're doing so much in Kubernetes, a lot of our administrator, other sysadmins, and our developers, they're, whether they want to or not, they're getting good at YAML. So rather than trying to push something else on them, something especially that's new to them, we've gone with YAML for our configurations for Traefik itself. We've also gone, we're, like I said, kind of piecemeal migrating the individual services, kind of domain name at a time. That ERP system that I mentioned earlier, we have, the domain name at erp.wm.edu / the individual application itself. And from a user perspective, they think of the individual applications, they kind of map to functional departments, things like financial aid, admissions, areas that you commonly find at a university, HR. So since each area kind of has its own niche thing, what we're doing is just kind of moving all of like production.erp.wm.edu all together at the same time. And by making that move together, it kind of makes things, it lets us put it in bite-sized chunks. Obviously, we're starting with our smaller services. Those kind of all moved within a couple hours of launching launching Traefik v2. And then it's just a matter of going through and rewriting those labels themselves, at least from a swarm perspective. In Kubernetes, it was a little bit easier just because the labels didn't really change. The ingress object still worked, at least as of Traefik 2.2. I will say pre 2.2, it was a little interesting. We weren't really sure what we were going to do. So if you're struggling with it and you've been struggling for a while, I would definitely recommend going and checking that out. So yeah, I could spend a long time talking about some of that stuff, but we can worry about maybe that'd be something, another discussion, since I think there's some other meetup presentations, maybe. Patricia.
About which topic are we curious?
I was just thinking on the Traefik 1 to 2 migration.
Yeah, absolutely. And feel free to email me if you'd like a direct line to any events and things like that are talking about the migration. Do you mind not sharing your screen so that we can see your radical face? Because otherwise the deck takes up the whole thing, unless it's stopped already. But
oh, no, there we go.
Perfect. Cool. Mike R has a question for us too. Thanks for that answer, by the way. Oh, and the question is, do you use Traefik to fail over load balance non-web services, e.g. MySQL, TCP tunneling, etc., to different devices like IP printers?
We haven't yet. It's on my, excuse me, it's on my to-do list of things I'd like to try. We just haven't really had the time, especially mid-migration, everything else. Kubernetes is relatively new to us. So we're still trying to get our, excuse me, we're still trying to get all that other stuff taken care of, but we're not using any non-HTTP routers or anything quite yet.
Okay, that's cool. Well, I personally am tapped out of questions, and I wonder if anyone else has some more you'd like to ask, or if Phil, you have any closing remarks or a song you'd like to sing, or
nobody wants that. No, I don't have any really any closing thoughts. I know this is kind of it's a very broad thing without a lot of specifics in here. other than this little dummy demo app. But feel free to reach out to me after the this thing is over. Like I said, you can tweet at me, email me, whatever works best for you. And I will do the best that I can to answer it. And I see Patricia dropped my Twitter contact information in the chat there, so I appreciate that. So no, I don't have anything else. I hope that it was helpful and not too overly vague for anybody.
Yeah, well, it was great. Everyone, maybe give Phil a bravo in the chat box if you enjoyed this session. We'll be sending out the recording to all of you shortly. And thank you for coming. Phil, you did an amazing job. And hi, Bala, by the way. And really appreciate your time. And thank you so much. And we're really excited to share this with the community now by way of video. So.
Awesome. Thank you.
Yeah, I know it's not goodbye, it's see you later, but also we do a fist bump and anyone in the audience who want to join us, but we always do this at the end. I don't know if you'll join me in one, but
Sure, why not? There you go.
Boom. So everyone stay well, stay positive, stay happy, keep your head up, as they say. And thank you again, and have a great night and a great day and whatever you're up to. So we'll see you at an event soon. Thanks, Phil.
Thank you.
Yeah.
Thanks, everybody.
Bye.
Bye.